Good morning. My name is Toby. As Enno said, I work for Intel Corporation. However, to be very clear, I am not here representing Intel. In no way am I representing Intel. They have no opinions shared with me. If anything I say sounds offensive, they probably think the exact opposite, and they are absolutely well-intentioned and well-behaved, and I am not in any way. I think that covers the legal requirement. As Enno said, I'm going to be speaking today about actually implementing dynamic access control and dynamic trust-based controls of your environment. When Enno first saw the presentation, we were still in the process of developing it and implementing it, and I was a much younger and more enthusiastic and optimistic sort of individual. I am now somewhat sadder and maybe a little wiser. The benefit is that you get to hear about what actually worked. So I'm going to go through a bunch of different topics, and this is the general agenda. I prefer questions during the talk, so please, if you have any questions, if I'm unclear, if I use a term that doesn't make any sense, if I start quoting random poetry that you find dull, let me know, and I'll move on. If you don't ask questions, I may. And I can guarantee you my questions to you will not have anything to do with information security or technology. They'll probably be anatomy, physiology, philosophy, other things that are much less fun. So it's better that you ask questions. Before we start, a joke. A man and his family walk into a talent agent's office, and he says, I have the most amazing, did you look this up last night? No? Oh, it's less fun. I have the most amazing act for you. The talent agent says, sorry, I don't do family acts. He says, no, wait, let me show you this. It's amazing. The talent agent says, all right, give it a shot. I'm now going to stop the joke because if I continue, I can guarantee at least half the people here will be really offended. If you're curious about what the joke actually is, look up The Aristocrats on YouTube. You'll see an entire documentary on the most obscene and funny joke you can possibly imagine. We'll leave it at that. There you go. Thank you. Or catch me tonight and I'll be happy to tell you a version of the joke. So, in about 2007, some teammates of mine and I were running into some of the standard problems that I think everyone in the computer security industry has been running into. If you do defense or IT security in any way, you know these issues. We were seeing cloud, we were seeing BYO, we were seeing small form factor, we were seeing iPhones, we were seeing all these things, and of course the users wanted to play with them, they wanted to access them, they wanted to use corporate resources from them. I got some great questions like, why can't I use my home gaming system to access corporate resources? Of course the response is, do you do your taxes on this system? No, of course not. Why would I do something silly like that? So why do you want to access our resources? But of course they do. We have to find a way to actually deliver this. The problem is, even today, most of your access control models are completely static. You either have access or you don't. And they're all focused on the user. So if I log in from my laptop, I get the same privileges I get if I log in from my daughter's tablet. This is a little strange, considering that doesn't make, those are radically different things. It's too intuitively obvious that those are different. If I log in from a secured data center, my access is the same as if I log in from a cyber cafe in Russia, or a cyber cafe sitting outside of an NSA site. These are bad things to do. It should be intuitively different. So we had to come up with a solution. And the goal was, in general, we wanted to be able to let users do some amount of work from any device they possibly could from any location. It was not necessarily going to be the same kind of work, but they were going to be able to do something from anywhere. We wanted it to be able to integrate with every single application in our environment, huge number, many thousands of applications, so that they could dynamically change the level of access that users had based on our trust of that user in that specific situation. We wanted the environment to just kind of magically know, and remember, I was younger and more naive, how secure your combination of user, device, and location actually are, so that you can actually give the right kind of access or add in additional supplemental controls, because really the answer of no is unacceptable. How many of you actually get to say no on a regular basis as IT people? You get to say no to your users? You don't count. Yeah, not many of us do. The answer always has to be, I'll find a way to deliver that. I'll find a way to make it secure. I'll find a way to make it acceptable. So how do you do that? This is what we were trying to do. You have to be able to characterize cloud environments in the same way you do any of these other combinations. So how do you do this? Well, we came up with this concept. We sat in a room in a basement of a data center for a week. They stuffed pizza under the door to us, and they didn't let us out. And by about halfway through the week, after we had killed off the weak ones and those who needed sleep and were showing signs of sanity, we finally started coming up with interesting ideas. What we came up with was this concept of a dynamic trust calculation. The notion is that you have a source trust calculation, your destination trust, and the result of this combination is your actual level of access. This gets recalculated every session reestablishment based on response from your detective controls, based on any change in the characteristics that make up the trust calculation. Part of what you're seeing here, and part of what we were aiming for, is exactly what FX mentioned, which is you have to be able to deal with recovery, you have to be able to deal with changes in your environment. So, how does this work? Well, the source calculation looks like this. Who are you? Who's the user? What device do you have? Feature set, operating system, hardware, anything that might make a difference in terms of the platform you're dealing with, and where are you physically? This is all divided by your actual confidence in this information. So if you have strong authentication, then you have stronger confidence in who your user is. If you have nothing but an IP address, then you have very weak confidence in your location information. If you have self-reported information, any of you remember there were a couple companies for a while that were offering computer security assessment via web browser plugin? They were selling this to companies. You remember these, right? Yeah, it was a great idea that you could assess the security and profile of a computer based on a web browser scan of that system. That's absolutely high quality data. That is right there. Destination, who are you? What the receiving application is, what capabilities the receiving application is. What do you want? What's the data classification? Where is the data located? And again, where the data is located comes into play for some interesting reasons. And the goal for this is that you make a decision. Maybe access denied, maybe access allowed. Really what you want, though, is more than either one of those, because access allowed is easy, right? We just give access, people get what they want. Access denied is frankly almost always unacceptable. You have to find something better. What do? You give restricted, monitored, modified, mitigated access in the middle. You change the access method, you reduce the access, you increase logging, you do something else. The problem is, in order to do this, you have to actually have the logic that takes that source calculation and that destination calculation and turns it into a decision about what kind of access you're actually wanting to give somebody. All of that stuff is what we started calling a trust model. My teammates, smart people that they were, looked at me and said, hey, Toby, you know, we think it would be really cool if you would take this on and run this whole trust model creation thing. We think you'd be the right person. It'd be a good idea. Never trust a Roman bearing gifts, right? Greek, excuse me. Never trust a Greek bearing gifts. So what did we do? Well, we created this thing. It was called, I started calling it a trust model. The trust model allows you to define the characteristics of a system and how you determine trust based on those characteristics. It defines what privileges are going to be granted as a result of it and what controls are actually required as a result of the trust and the privileges. This sounds pretty simple, yeah? Pretty straightforward? Okay. First, some definitions. You've got two pieces of the trust model, a trust level and an access level. The trust level is made up of a combination of the confidence you have in the user's identity, the device's security, the location security, your method of access, and it defines an increasingly restricted set of who can connect with what and from where and how. This is getting a little more complex. Access level, the amount of consequence possible. Notice this is not just about data classification. Lots of people tend to default to think only about data classification. It's an interesting thought, you know, data classification, it's an easy concept, people like to hold on to it. But the reality is, how much classified data is there in something like DNS? Not very much. How about DHCP? Not a lot of highly sensitive data. How about your WAN routing configuration? It's not particularly sensitive. I mean, you don't want it messed up, but it's not particularly sensitive. How would you feel if they went down? All of a sudden, it really starts mattering, which is why we talk about consequence, much more specifically than data classification. So these definitions are very abstract. Don't worry, we'll work through it. A simple, very basic sample of what an access level definition could look like. This is a very simple one. A friend said this was useful enough that I should move it to earlier in the slides, so don't worry, we'll bounce around to it. But you've got an increasing level of access. You've got a data classification or consequence, maximum privilege that you can feed in. You can see how this flows. Yeah? Any questions on this? Don't worry, we'll get back to it. Sample trust level. You've got the trust level. You've got a series of characteristics. You've got the definitions for each of those characteristics. Notice that in here we've got very, very coarse buckets. We've got very large-scale definitions. This is one of the things that we ran into, and I'll tell you why in a little bit. This was not where we wanted to start. We wanted to start with ultra-fine grain. We wanted to be able to say, we don't care what your operating system is, but we do care about what your encryption algorithm is. We care about what your ASLR quality is. We care about whether you implement depth. We care about your key length. We care about your privilege model for the system. We care about all of these other things. We want to be able to evaluate them very distinctly. We care about what DLLs you've got. We want to be able to evaluate each of these characteristics very distinctly. This is much closer to where we ended up, and you'll see why in a moment. So what do you do with these things? Well, the basic concept is when you determine something's trust level, then you can also define the default set of controls that you need for it. And then you will give it direct access to the access level. This looks dead obvious. This is really silly. Why would this need any sort of complex logic? Why would you need any logic at all for this? The reason you end up needing some logic is because what you can do then is this. And this starts getting really, really interesting to customers, to employees, to users, to the people that you start working with. Because all of a sudden, what you can do is if you've got a low trust device, or a moderate trust device in this case, and they want access to low sensitivity content or low consequence information, you can start removing things that annoy them. You can start removing controls that are expensive or complex to work with. You can reduce your cost. You can improve your user experience, which matters to everyone. This makes everyone's life easier. You end up actually creating better efficiencies. You end up being able to spend your time on things that matter. This is where it starts being useful to have the difference between the trust level and the access level. And this is why you start needing something like a trust model. Now, do any of you work in healthcare? Anyone in healthcare? No?
Probably in parallel.
In parallel?
The talk on medical.
That's right, the medical. Yeah. So they're probably all over there. So one of the interesting things, years ago I was involved in a little bit of the healthcare stuff. And one of the things that came up was that it's a real problem to do data security for healthcare environments because you don't want to risk somebody's life by not having access to data. This is a critical problem. You have to find ways. If a doctor is about to give you a shot, they need to know whether you are allergic to what they are going to inject you with. And if they have to do a request for access to that data, you're in real trouble. You're probably dead by the time that happens. So they have this term. Say again? Yeah, it doesn't go well. They have this term that they use, which is called break glass. The idea is like with the fire alarm. In case of emergency, break glass. Anyone can do it, but you see that it has been done. You have the ability to detect. You have emergency access. Intel runs, I don't know if you're aware, they do a lot of manufacturing. Maybe you're not aware. They make things. It's their lifeblood. It's what they do better than anyone else in the world. They have higher quality chip development and chip manufacturing than anyone in the world. A coworker of mine said, I want to be able to sit in the most insecure environment you can possibly think of and do full manufacturing facility administration from there. Why? I don't know. I'm just going to make your life difficult. But make this possible for me. So I started thinking about how you do this. The beauty of the trust model is that you can start defining this concept of break glass access. Let's say you're nowhere near your computer. You've had a couple beers too many to drive, 15, 20, 30, something like that. You really can't drive, but you need to get online and deal with something in the emergency. If you are in a position where normally you would not be able to access it, if you are in this scenario where you were sitting at trust level 1 and you need to be able to get to trust level 5, normally you're fucked. However, when you start looking at this sort of model and being able to look at the adaptive controls, you have the ability to say, this is an emergency, I want a break glass option. Now, the normal answer for how you implement a break glass option is you say, all right, fine, we're just going to break all the rules. We're going to ignore it in this moment. We're going to accept the risk. How many of you heard the phrase accept the risk? Yeah? How many of you like the way that sounds? No, me neither. It give you a little, feels a little dying inside. You just kind of want to cry a little bit. Yeah. So it's not a good thing. So the goal here is to allow you to create the option of how to do that emergency access, that emergency elevation, without having to accept risk. One of the things that I've concluded as part of creating the trust model for this is that you should not have to accept risk. You should be able to choose to do so, but if you are being forced to, it means you were not sufficiently creative in your design. You didn't come up with the right controls, you didn't have the right options, you didn't plan ahead enough. This is where it starts getting really useful, and this is where we really started getting very positive response. This is how we actually got funding to build it. Assuming we have time, I'll actually show a demo of what this tool actually looks like, and I've got it on 2 devices. Another option, another example. This is what variable authentication looks like. So if you go back to the previous model, you have the option of being able to reduce controls and gain access to more stuff. If you are along the top, you see your device trust level. Along the left, you see your target access level. So you can think of this as where you want to get to. If you're on a strongly secured device and you don't care about the high sensitivity of the data or the action, you can give somebody really weak authentication and all of a sudden their user experience is better. Their life is better, it gets in their way less, they're more efficient. This is a good thing for them. This allows you to give them better access, and this defines that sort of dynamic change in access. Now, what you're seeing here is an example of why this has been fairly hard to visualize, and one of the problems that I had with it. Because you have to figure out how to go from a view like this and like this to a very 4 or 5 dimensional view, and it's a pain in the neck. I would love to hear people's thoughts if you have any afterwards. So some of the requirements when we sat down to write the trust model. We needed something that can be verified. It has to be able to be checked to be correct. You don't want non-deterministic endings on this. You need it to be specific, and you need it to be able to be predictable again and again. It needs to be logical and defensible. Why does it need to be logical and defensible? Well, because somebody's going to come along and say, you're not letting me do what I want. I think your model is messed up and wrong, and here's why you should make an exception for me. And it's interesting. You'll end up with actually, at least I ended up with 2 responses. First was, this is too complex. We need fewer levels. Why don't we just have 3? It was the default answer. And then as soon as there was something that they didn't get access to that they wanted, the response was, you need more granularity, you need it more fine-grained, you need it to be more complex. So you have to have something that is consistently defensible and explainable to people so that you can have very clear distinctions. Now, if you go back, and I'll do so in a moment, to the trust levels, you'll see it's very clearly distinct at each level where the break is. It's a very logical break. Doesn't need to be consistently changed. You need something that doesn't have to be updated every month when there's a new piece of software being released. Enables flexible controls, eliminates the unnecessary controls. You need this to be predictable, because if users can't understand it and anticipate what access they're going to have, they're going to get confused and they're not going to want to use it. It needs to be explainable not just to yourself and to your peers. It needs to be explainable to the engineers who have to build it. It needs to be explainable to the users who are going to have to interact with it. It needs to integrate smoothly with existing solutions. If you contradict everything that you've implemented to date, you're not going to get this accepted anywhere. It has to have a good user experience. And finally, you can't magically come up with new things. You can't just magically say, all right, we're going to have trusted, secured GPS location data. We don't know how this will come into exist, but we trust that a ferry will come along and deliver it to us. So you have to work with what you've got. So in theory, this is where we started. And this is what you saw. We were going to have a highly granular and highly dynamic model of implementing the trust model such that it could respond to subtle changes, the tiniest change, a DLL change in a system. We were going to implement this. It was going to directly integrate with all of the applications in our environment so that you could transparently manage access to each one of those applications on the fly. So that you change a little subtle thing, your behavior changes slightly, and we can adjust for that and we can modify other controls. We were going to actually take location into account in a very fine grain. We had this notion that we were going to differentiate between airports and coffee shops and your home and the office and which countries you're in. That was the theory. It was a great theory. I loved this theory. I was really excited about it. Then I started trying to actually write this. What you run into, highly granular, ends up meaning really, really hard to validate. You cannot validate this. At least I'm not smart enough to do a lot of the validation necessary for this. This is very much like writing a provably correct operating system. You know, this is a from the Rainbow series, the Orange Book, what's the term for a provably correct operating system? There's an A1 operating system. This is really hard to do. As soon as you get complex, it becomes impossible. Highly dynamic means that users are confused. If their access changes because they walked from one room to another, they're going to be really upset. They don't like this, it's a problem. And more to the point, it's difficult to support. So if the tech support people can't determine whether a loss of access was a mistake or intentional, how are they supposed to say, yes, this worked correctly or not? What's going to be the answer? Let's turn it off. If they turn it off, you lose. So it has to be able to be explained. Applications are really not very good at dealing with the concept of anything more than a user. So what do you do about this? Well, you can start creating multiple users. How many people in this room have 2 devices on them right now? At least 2. How many have 3? Any more than 3? No? So I have at least 3. I have 4 right now. One of the ways you can implement this is you can create separate user IDs. So you can have Toby plus laptop, Toby plus phone, Toby plus tablet, Toby plus refrigerator, whatever you've got. Of course, this means that if you have 10,000 users, you've just multiplied that by 4. If you've got 100,000 users, you're rapidly creating a ridiculously large user base. And how do you maintain those separate privileges with the sufficient level of overlapping characteristics? Apps don't do this well. What do you do when you change the permissions in the middle of a transaction? Yeah, it breaks things pretty badly, doesn't it? All of a sudden, something you were in the middle of doing, and your app just says, oh, no, your permissions have changed. Sorry, you can't go back and cancel this transaction because you don't have that permission anymore. Oh, and by the way, you can't actually move forward with this transaction. So what are you going to do about this? In addition, how do you get all of these apps rewritten? You know, especially if you're dealing with apps that are not your product, if you're dealing with internally supported applications. These are things that very likely don't have a lot of money in them. Lots of dimensions. This is hard to visualize. When I started looking at all of the characteristics just in the trust model alone and trying to explain how a reduction in one piece could result in a need for increase in something else, and the concept that you had to have multiple factors that moved up simultaneously while giving access to something, it's really hard to explain and visualize this, and I'm not a good enough artist to draw this for people. Trying to describe it is difficult enough. So if you can't visualize it, you're not going to be able to explain it to most people, and eventually you want to move on to other work. I'd like to go do other interesting things. I've done this for a while. I want to do something else. You need to be able to pass this along to other people. Location. Location was probably one of my largest disappointments. What do you trust? None of these are trustworthy. You can't trust. You can maybe trust GPS data a little bit. Of course, the question is, how do you get that GPS data? You get it from the application. We trust applications, right? That's trustworthy, right? You trust you trust the operating system? Sure, right? Why not? And of course, nobody can actually spoof GPS. That's impossible, right? So what are you going to use? Well, the interesting thing is that none of these are worthwhile. The only one that we actually found that we could trust was our own logs of devices connecting to our network. So in the end, all we could effectively determine was, are they on our physical premises, or are they not? Are they connected to our network, or are they not? That's awesome. But if you've got a device with a cellular modem in it, what difference does it make? I mean, what's actually changing in their security based on that location? Much less than you'd actually think. We did start taking into account, but really nowhere near the level of subtlety and interest that you would actually think. This is coming. At some point, this is going to be the case. And there are some interesting products. There's a company called Perspexis that does a cloud proxy. And one of the things that they can implement is they'll use very weak geolocation to determine whether you should have access to something or not. This is interesting if, for instance, you're dealing with the German Works Councils on privacy, and you need to make data only available from within Germany. It's coming, but it's not here yet. So we started looking at this. Why did we build it? Well, the answer is that we looked around and nobody was actually implementing this. We started thinking about this 5 years ago. There was nothing on the market. These all things are starting to come along. There's now actually one company, Mobile Systems 7. They're really interesting. They're absolutely worth looking at. If you are curious about this sort of thing, you should go check them out. They are really doing neat stuff. They hide the entire trust model. And they do it very intentionally because it's a pain in the neck to build one of these, and most people don't want to bother. Microsoft have got a little bit, you've got adaptive authentication, but it's really not adaptive access control. It's just changing the level of authentication, and that's probably the smallest piece of this. NIST did a little bit. There's nothing open source anywhere. So we had to build it. Any questions at this point? No? Blindingly obvious? Confused as hell? Somewhere in between? You're awake, so I'm not seeing too many people. All right, we'll continue. What did we do? We started with a natural choke point. We wanted to implement this internally. We wanted to implement this against all applications everywhere. There's a very odd spot right there. Unfortunately, the reality is that getting it tied into all the applications really was not going to be a feasible place to start. So we looked for a choke point. Remote access was the right, simple choice for us to do so. We decided we would build there and we would prove the system and we would build out from there and expand it out from there. And we're actually now at the point where we are expanding out. We encoded the trust model itself into a database as the fundamental logic for the system, simply because it was easier to do it that way. This was a first implementation. It was a proof of concept. It was the place to start. The gateways query the trust broker to determine how to handle the connection. You get an appropriate access level based on that result. Very simple. We did this based on UAG. You can do it on F5. You can do it with anything for whatever remote access. In UAG, you have the concept of a trunk. You can deliver different trunks to users. We created a front end for it that would allow us to dynamically change the authentication mechanism, and I can show you that at the end. However, this talk is not about that piece of it. This is about the actual trust model that we built. First, you wanted to find what doesn't change. So as I started looking at this problem, I realized it was getting really big and really ugly. You wanted to start eliminating as much of it as possible. A very smart friend of mine, a reverse engineer, said that when it comes to reversing, what you really are doing is you're not trying to figure out what all of the code does. You're trying to figure out how much of the code you can ignore so that you don't pay attention to it. Dr. Raid. Yeah, and it was brilliant. And so I started looking here to what I could eliminate. This doesn't change anything about user privilege. This is an important one to understand. Users don't get any more access than they would have for themselves. You're just modifying that level of access. This doesn't change regulatory requirements. You've still got privacy regulations, you've still got SOX, you've still got HIPAA, you've still got anything else that you can come up with, financial laws, all of these sorts of things. They still apply. Nothing changes about any of them. In fact, if anything, this is just a way of reinforcing those. You define your destination variables. You need to know what your data classifications are for the environment. You need to know how many levels you're going to have. I started with as few as I could come up with, and then I got pushed to add a couple more. And at this point, I'm fighting aggressively. We've got 5 and a bit, and I'm fighting aggressively to keep it out from growing any more than that. I started at 4, and we're now dancing around 6, and it's not pleasant, but it's where we're standing at for the moment. Define your source characteristics. This is where you start getting into fun things. Go wild, play for a while, think of all the sorts of things that you might want to care about inside of a platform, enjoy it, luxuriate in the joy and the naivete of being able to actually come up with all these things that you care about, and then crumple it up and throw it away and start getting a much more narrow list of things. But you are going to come up with this long list of stuff. Device features, hardware crypto module, interesting things, TPM, all the sorts of things, operating systems. You want to fine-grained granular access control inside the operating system. You want actual different users. So for instance, if you actually care about somebody being able to be separated into more than user and administrator, you might as well say goodbye to Android, right? Because it doesn't have any other options. You're either a user or you're admin on Android. You want more fine-grained than this. You start thinking about these details. Determine what options you have for mitigating controls. These are all the things that are going to allow you to elevate or respond to any of the unusual situations. These are the tools in your toolbox. These are all worth considering. Are any of them perfect solutions? Absolutely not. But there are things that you use to say, all right, you are at a lower level of trust and you want to get to a higher level of access. These are some of the tricks that we can use to modify it. These are some of the tricks that we can use to reduce the risk and maintain an acceptable level of risk so that we're not actually taking on more risk than we already have. Figure out how you're going to collect the information. Do you want to get it from the device? Do you want to get it from the infrastructure? I'll give you a hint. Much of the information that you need, you're probably already collecting. Active Directory? Who's using it? Yeah, most. MDM? Yeah, somebody's using it. ActiveSync? Yeah, you've already got a huge amount of this information coming into you. You've got DHCP data. You've got user information. You've got a huge amount of information at your fingertips. You just need to pull it in and start looking at it in combination. Figure out how each of the characteristics fit together and how they're going to impact each other. So this is where you start getting into the really hard puzzle. Some characteristics, as they get stronger, make other characteristics less important. So for instance, if you have a really well-secured device, authentication doesn't need to be quite as resilient. If you've got a very weak device, if you've got a very insecure device, you need authentication that's not going to be able to be duplicated. If you've got a very secure location, maybe you don't actually need transport layer encryption as strongly. Maybe you can use self-signed certs. Maybe you can do other sorts of things. This is where you start getting into the actual mapping of controls and characteristics against each other. You're going to be writing this all down. Find some way to write it all down and to start tying it together. I used a combination of pad and paper, Visio, OneNote, text files. I tried every possible thing I could come up with, and I didn't find one perfect model for it. If anyone has ideas on ways to put this together, I'd be really interested to hear it. Separate out your source and target. I didn't actually want to do this at first. At the beginning, there was only trust level. There was not going to be any access level. The problem is you can't talk about the elevation or the drop down from a trust level to a different access level unless you separate out those concepts. And so you need to have them actually distinct. So you can say, I'm at trust level 3 and I need to get to trust level 5. I'm at trust level 2 and I need to get to trust level 1. Or excuse me, trust level, access level. See, I still do it. You want to keep them separate because it lets you talk about that differing set of requirements and that offset. Leverage all the existing information sources, like I said. You're going to take advantage of these. So you start by classifying the applications into access level. You're going to end up needing to put together some definition of process for this. Rather than trying to talk about the applications and the details of what they're actually doing, start defining an application's access level itself. You start with coarse-grained definition, this application for this purpose. What this ends up meaning is that you actually have multiple applications for the same purpose. So you think this is a little weird, but you realize actually you're probably already doing this today. If you think about it, you're probably using one mail client, one native mail client, or multiple native mail clients. You deliver email separately and differently via ActiveSync or via a MDM to small form factor devices. There are multiple different ways that you handle this. So you're already doing something similar to this today. Use flexible language. This goes back to the problem of wanting to have something that maintains and survives over a longer period. If you get too prescriptive here, and you're going to see me talk about this again and again, if you get too prescriptive, you're not going to have the flexibility to say, how do we deal with this with a new platform? How do you deal with this with a new environment? One of the interesting things, I started telling you about the desire to say, all right, we're going to talk about ASLR, we're going to talk about DEP, we're going to talk about kernel security, we're going to talk about access control model, we're going to talk about DLL signing, we're going to talk. This gets impossible to manage. I realize, though, that when we talk about privileges, we frequently use containers. We talk about buckets. When you say admin access doesn't mean anything. It's a term used to describe a large amount of privilege, right? So what you're talking about here is you start creating those buckets of characteristics and descriptions. So you can say things like, you must have a modern operating system, you must have a managed device, you must have a current patched system. You are able to create these buckets that make it much easier for you to reason about these sorts of things. You start defining your privilege sets. Again, these all have to be generic enough that you can easily defend them and break them into multiple chunks. Data classification, user versus admin versus big admin. How many different levels of administrator would you want to have? Thoughts? You separate out your user administrators from your device administrators? Do you separate out your client administration from your server administration? Do you separate out your server administration from your infrastructure administration? Infrastructure from your high sensitivity application? High sensitivity application from your SCADA? You start separating out these buckets, you want to think about how many you have. Now, all of a sudden, when you start looking at this, you'll see that the trust model that you've got here, you start wanting to have it break very cleanly between chunks. So data residence. At this level, there's no information. Still no data residence, very cleanly, limited data residence, always encrypted, full data residence. User authentication device management, nothing at trust level 0, still nothing, partially managed, fully managed. Clean, defensible, explainable blocks so that you can say, this is why there is a difference between trust level 1 and 2, trust level 2 and 3, trust level whatever. This is how you start defining all of those characteristics against each other. Likewise here, how do you describe it? Full standard user privileges, and you'll actually potentially break these out into more detail than I have here. So we actually add in additional layers here, but this is where you start being able to define those different characteristics, because I can guarantee you somebody's going to come along and say, I think that I should be able to do this thing from a lower level of trust, and that it should be at the lower level of trust permanently. And you need to be able to explain very clearly why it's not a subtle distinction, why it's a big bucket and a big, clear, obvious one. So, define your requirements. Use big buckets, like I've been saying. Windows 7, Windows 8, iOS current version, Android current version. You don't want to try and say, must have ASLR with this level of randomness. I was really disappointed when we couldn't say things like that, because really that gets you to an interesting level of granularity and much more nuanced, but it's impossible to manage. It doesn't work. You cannot manage at that level of complexity. Nobody's going to keep track of it, and nobody's going to be able to understand it. And in the end, it doesn't change often enough to matter that significantly. What have we gotten so far? So y'all have been fairly quiet, but the interesting thing is we've actually gotten really good results. Users have been really impressed with it. We've been getting the process of evaluating applications. We've got that pretty standardized. App owners are getting used to it pretty regularly. And we actually now have it fully implemented. Would you be interested in seeing what this looks like? Mm-hmm. Yeah? Okay. So I took, my daughter is here with me, and I took advantage of being her parent to abuse her phone. Because I can do that. So let me start VLC. Kate, can I have your phone? Thanks, officer. Is it unlocked? Yeah, there we go. Okay. Yeah, it's true, I do. Okay, so VLC, capture device. Let's see how this works. Perfect. Okay. So this is my phone. This is a fully managed device, MDM controlled, current operating system patched, up to date, running all the necessary controls. It is a small form factor device, and there are limitations to what it can do, so it's not as secure as you might want. However, let's see what this looks like. I love that it's all backwards. Okay. Let me see if I can do this. Oh. Okay. So, this is probably unreadable. What you should be able to see there is, based on security definitions, your device is trust level 3. And you'll see an entire list of applications which are being whited out because this is hard to look at. But Notice that it went in directly to it. You didn't see me do any authentication. That's because the list of applications that I'm accessing are all either at the current trust level or a lower trust level. This is using a hardware-tied certificate that's locked to the device. The device is fully managed and fully controlled. It means that we've decided for the appropriate level of access, we don't need to do any additional authentication. Now, in contrast, on Kate's device, I load, I tap, it says determining trust level. On this one, it kicks me in and says, oh, wait a minute, you actually have to have additional authentication. We're going to require you to enter an OTP. So I say, yeah, go ahead. It pops me in and says, authenticate. So I go in and I give it actual authentication here. And no, I'm not going to show you what I'm doing. But it's, in this case, we use OTP plus PIN. And on this one, well, by the way, the session lifetime is defined in part by your location. So on this, one of the things that we've done is if you're in a position where your device is likely to be stolen, your session lifetime drops down to ridiculously short. And if FX is around, you can't actually do anything anyways. So, and again, what you see here is a different list of applications. Now, the interesting thing is that there is some similarity. Let's see if I can, it's not going to be visible enough to actually give you a good distinction, unfortunately. But there's actually, so on this one, maybe you can see the trust level there. Can you read that at all? Not really. This one is trust level 2. Unmanaged device, unknown device, but it does have certain characteristics that are installed on it. There's certain information that we've known about it. Same operating system, same user, different applications, different level of privilege, different level of access, but I can still do work if I need to from her device. So if I need to get to certain kinds of information, for instance, if I need to book a bridge, a phone bridge or a conference bridge, I can do it. If I need to look up employee data, I can potentially do certain pieces of it on this device without actually having to change the security of the device, without having to be more invasive than really is necessary on the device. This is what people have been asking us for, and this is why they like it, because all of a sudden when you have users who don't want you to control their device, you can actually give them some level of access. So effectively what we've got is same user, same location, two very different levels of access from two distinct devices. And if I uninstall the MDM off of here, this will dynamically drop the session and I can reestablish one and it will be a lower level of trust. So that's the demo. Hopefully that was interesting. Future work, where we're going off of here. We're turning it into an API currently, so we actually are driving towards the model of being able to integrate this directly with applications. How quickly applications are actually able to use it, it's going to be an interesting question. We're not quite sure. I've started playing with XACML a little bit. Some of the XACML-based policy decision systems are really interesting for this. And they look like the right way probably to describe a lot of this language. Some of the modeling tools actually look pretty good for it. Finding options for dealing with legacy. We're still trying to figure out what this looks like. It's probably going to end up looking very similar to what is on here, which is basically a gateway that gives you control and limited access to it and creating multiple different levels of access for the different applications. And finally, integrating the dynamic modification of detective controls. This is a challenge. You wouldn't think that it would be in the first place, but how many of you remember IDS-based shunning? Any of you remember? Yeah? How many of you made the mistake of turning that on? Yeah, you let your IDS say, hey, wait a minute, that looks like a bad IP. Oh, look, we've just blocked 0.0.0.0 slash everything. We've just destroyed our entire world. Yes, so very, very subtly and very slowly we're moving through and moving into this model. Yeah?
How many applications did you actually cover? Internal applications?
So right now, percentage. Right now, we're probably in, given that we've got thousands of applications, we're probably in the under 10% right now. And part of that is because we are allowing the application owners to push the implementation rather than requiring them to move into it. So we've been letting them come to us at their own pace based on their user requests. We've basically been letting user demand drive the move of the applications into the space. And as that's moved along, it's started to accelerate. And so we're seeing many more apps on a regular basis come in. At this point, we're seeing a couple a week added. And we're getting to the point where it's actually not too hard to do. Conclusions. A trust model will actually allow you to give users increased access without increasing your risk. If you're accepting additional risk, you really are doing something wrong. You don't have to do it. You can choose to do it because you want to save money, but you don't have to accept additional risk. You can actually give people access with their BYO, with their personal information, with their personal devices, all these strange places, without actually having to accept more risk. On that note, thank you. Troopers is over, apparently.
Track is supposed
Yeah.
building stuff, not breaking stuff.
Right, exactly. You're going to have to make this supportable. The nuanced and finely subtle things are not going to necessarily be what you start with. This has to be something that your technical support team can actually help your users implement and use and take advantage of. You have to be able to have engineers that can build it. You have to be able to explain it to everybody. You know, the users were bad enough, the engineers were a pain in the neck, but management was the real challenge. Finding ways to explain how this worked to your managers was a real difficult thing to do. Doing it right is going to take a lot of time. I thought this would be a fairly fast thing. I got asked about it in November of one year and figured, okay, this will take me a month or two. It won't take a tremendous amount of time. I was still polishing it a year later. I'd gone through so many revisions and so many variations on it. It just took a tremendous amount of time to actually implement and to do it right. And you're going to want to take the time because you do need to do the validation. The validation actually ended up being probably one of the biggest challenges. Is I would start the process, I'd write it out, and I'd start doing the validation, and I'd either run into the fact that I couldn't figure out how to validate something, or I would find a hole in my logic, and then I'd have to go back and I'd change it, and then you have to start the validation process entirely over again. It's a pain in the neck. Keep it simple. Keep it really simple because, frankly, you're probably not clever enough to do all the interesting things that you can think of. I wasn't. I'm looking for people who are more clever than I am to do more of the interesting things, but they have more fun doing other stuff. Granularity is going to spiral out of control. Every time you add a variable, every time you add a dimension, this starts getting bigger and harder to handle and manage. This is the end of the talk. You guys have all been fairly quiet and I've moved quickly. Any questions at this point? Yeah.
We've been talking that users are very excited about it and happy about it, but what about your security guys? So people who...
Well, so I am the security guy. I'm actually...
There's only one?
Well, no, there's a huge number of us. So that's actually a really interesting point. The people who came up with this concept were the security team. This came out of the security team. It came out of our frustration of having to say, you want this new thing, we're going to have to spend $1 million to build all the infrastructure for it. We don't have anything that crosses over. We don't have anything. One of the things that I did very intentionally is when I started doing the security architecture for this, I had other people in the security organization take over the penetration testing and the security review for it. You can't edit your own work, fundamentally, and you can't debug your own code. It just doesn't, you can't do it well. So they're actually pretty happy with it. One of the challenges I'm still running into with some of them is the issue of explaining it to them, and that goes back to keeping it simple enough that you can actually communicate this to other people. But for the most part, yeah, they like it actually quite a bit because it gives them the option, instead of having to accept more risk and accept bad ideas, they can say, all right, what mitigating controls are we going to use? What options are we going to have? It gives us significant ability to not be forced into a corner. And the problem of being a security guy is somebody's going to come along and say, I know that you need strong authentication, I know that you need a secure connection, I know that you need total device control, but we have an emergency and somebody needs to update our WAN routing tables from a cyber cafe in Russia. And they have no, and they have no authentication and they have no hard token, and you can certainly trust their connection because it's, or who would bother to compromise a random cyber cafe in Russia? Yeah. So they're pretty happy with it, and the beauty here is you can say we actually have a model that allows you to deal with that situation.
And could you further describe the breaking glass?
Thank you.
Sure, absolutely. Sure, so I'll give you an implementation, or an example, for exactly the scenario that I just described, which is you have an emergency and somebody needs access to some application that is not in this set, very intentionally, or they are at a friend's house, they're at a party, and they need emergency access to something that is just not accessible. What we created was a model that allowed you to temporarily get access. Well, actually, I'll walk you through the model that we used. We created a situation where if you are a approved administrator with a certain level of privilege and your management has agreed to it, you register your phone number. You then go to an externally available website. The externally available website, you go and you log in with your existing OTP and a couple other credentials, and you say, I need to start an emergency session. If at that point you get a response back to your phone that's a session token, and you then go to a separate site, use the session token in addition to the various kinds of authentication, and at this point you have said, I need to start an emergency session. We've given you the ability to, for a very limited period of time, start that session. And once you've started that session, you then get a full terminal remote access. At the same time, your manager is notified, you're notified, and the other people with the same kinds of access are notified, so that we've got multiple levels of notification. You also are only allowed to do this a certain number of times. We've debated how many times, but we've basically said you don't get to do this more than about twice a quarter.
And will the security operating center
Yeah. Oh, yeah.
on this and let's say investigate what you were doing?
Oh, they'll actually know in real time. So the question was, will the Security Operations Center? So the Security Operations Center is one of the groups that's notified. And while they may not go and monitor the application that you're interacting with directly, you can expect somebody to show up at your desk the next day and say, why were you doing this? And they'll actually go to your manager as well and say, were you aware of this? Did you approve it? Do you know about this? Now, will this prevent somebody from doing something horrible in that window? Not necessarily, but that's why it's a break glass scenario. The idea is that, yes, we are giving this emergency access. The other thing is that we very intentionally didn't make it easy. I just described a fairly complex and painful set of steps, which if you're 3 sheets to the wind at a party, you really aren't going to want to go through. But the point is that this isn't supposed to be easy. This is supposed to be emergency access that you don't use very often. And by making it only emergency access, you free yourself from a lot of the standard sorts of positive user experience issues that you would run into. Does that make sense?
Has it been used yet? The break glass feature.
No comment. We've tested it actually a bunch of times. We try to avoid using it. I mean, really, if you're using the break glass option, you missed something up. But yeah, we've had a couple cases where it's actually been necessary, and people have been. I think the first time it was very satisfying. The first time the admin was fetching and bitching and whining and moaning about how difficult it was to use, and we pointed out that the other option was that they could get back in their car and drive 2 hours into the site and do everything that they needed to from the physical location because they were the ones who managed to be in the wrong place when they were on call. And then they shut up and said, thank you very much for creating this thing that makes our life so much more easy. It worked pretty well for that. Other questions? Yeah.
Have you tested your practical implementation for deadlocks? I mean, for example, for this breaking glass option, you rely on OTPs. What is if your OTP system is down and the admin on a party needs to repair it?
Yeah, absolutely. So to be clear, that's one of the break glass options. That's not the only one. The question was, what do you do about deadlocks? And this goes back to standard disaster recovery sorts of questions. Is, you know, if you're depending on an authentication system and the authentication system goes down, what do you do? And the answer is, we've implemented different break glass solutions for different parts of the environment, and we've also got standard disaster recovery implementations that handle a lot of those scenarios. It's like you always have a dial-in line for your router because you really just always need to make sure you've got serial access.
So a special plan B?
Not necessarily a special plan B, but a set of distinct disaster recovery options that are pretty standard. This goes to, in some level, this is kind of the parts that don't change. You know, for every critical piece of your infrastructure, you need to have a disaster recovery plan and a business continuity plan. This is no different. So you implement a disaster recovery plan, you figure out how you're going to get in. If this system is down, yes, you're not going to be able to use it if the authentication for it is down. If that happens at the same time as other critical infrastructure failures, then you start having cascading consequences, and that becomes a question of how many simultaneous failures you want to plan for and budget to cover.
But in your trust model, admin access is included. So it's not only control for normal office users, it's also offering a trust model for administrators on different levels.
Yeah.
But in this case, would it not be necessary to include this disaster recovery options also in the trust model, so you know about it?
Yes, but it doesn't become, the question is, why would you not include the disaster recovery options as part of the trust model? And the answer is, you take it into account in building the solution. You don't necessarily have to characterize it as part of the trust model itself. So you have to have a plan in the disaster recovery model. You have to have a plan that there is one, but it's not part of the trust calculation because it's orthogonal. It's a separate function. It doesn't need to actually be integrated. I can try and give you a better explanation. We should probably do it afterwards during a break. Okay.
Yeah, I mean, you'll be around
I will.
during the whole conference, and Toby is in general a very accessible guy. So
I'm easy to find. There are also more papers around this. Are we out of time? Yeah, okay. There are papers on this on Intel's website. You can find them. You can also bug me endlessly, and I will happily talk your ear off about this. If you have ideas on making it better, I'd love to hear them. There are very few people that are working in this space, and it would be really neat to get some better ideas. If there's nothing else,
great
then...
talk, very interesting, I think. And,
Thank you.